section we are going to build the neural network. So let us start. Let me define the architecture that I will be using. So I have input layer, architecture. Let us see. So we have input layer. Input layer will be having 40 MFCC features. Okay. Then I have hidden layer 1. This will be containing 100 neurons. I'll put hidden layer 2. This 2 will contain 100. Let me put 200 neurons here. And then I will give the output layer. The output layer will be containing how many outputs? Very interesting. For that, we need to check metadata dot class dot value underscore counts. Not class, rather I will put it in square bracket. Sorry, not value underscore count, n unique. How many unique are there? The total 10 output are there. 10 output labels are there. So the output layer will have 10 neurons. 10 neurons. Not, yeah, neurons, okay. So now that we have decided this, let us begin with it, okay. So for that we need to from TensorFlow dot. No, see, I haven't installed TensorFlow here. TensorFlow dot keras dot models. Import sequential. It is not working because no module named TensorFlow. I need to install the TensorFlow module. Let us see. Pip install TensorFlow. It might take some time. See, we are working in a different environment, right? So in that environment, we need to install our TensorFlow module. Let us wait for it. While it is installing, I will write the next line of code. From TensorFlow.keras.layers. Import dense dropout. Still it has not done. So we are importing sequential dense and dropout. We will be adding dropout layers also here. You will see how it is done. Okay, it is completed. See, I have a tick mark here. Let us move ahead now. So model is sequential. I have initialized it now. Now here I have to check. Wait a minute. So hidden layer 1. Model.add dense, and in dense I have to add 100, comma, input shape will be 40, comma, and activation is relu. We are done with this. Okay, I think this is fine. I might be missing something. I think this is in dense only. Yes, input shape and this activation also it is in dense only. So this has to come here. Now I will add model.add dropout. And dropout I want 0.3. This is fine. Next we go ahead with hidden layer 2. Model.add tens 200 activation equals to relu. This is also done. Next I have to add the output layer. In the output layer, model.add dense 10 and activation will be softmax. I think I need to keep this small. Okay. So there seems to be some error, cannot convert 40 to a shape. Why he cannot convert 40 to a shape? I think instead of just putting it as 40, I need to put it as 1D array. So here, comma, comma, and this way I have to put it. Okay, it seems it is done now. I think it is fine. Let us move ahead now. Now I need to see, I can check the summary. Model.summary. What is the summary? Non-trainable, trainable parameters, dense layer, dropout layer, dense 3. Okay. Okay. So we are done with this. Now let us compile the model. Model.compile. Now what is the optimizer? I have to specify the optimizer. I will use Adam. What is the loss? I will use categorical cross entropy. Rather, I will use sparse categorical cross entropy. And metric will be accuracy. METRIC metrics is equals to accuracy. Sequential has no attribute compile. COMPILE. Model.compile. Okay, I think it is done. Yes, model.compile is also done. So we have made an architecture first. We have then compiled it. Now I will fit the dataset on it. So history equals to model.fit x underscore train comma y underscore train. Next I have to give batch size, which is 32. Next I have to give epochs. Let me take 50 epochs. Validation split equals to 0.2 and verbose equals to 1. I think we are done. Let us go ahead with it. Okay, so the training of the model has started. So let us see how much time it will take. It is bound to take some time. But since it is simple dataset, it might not take that much time. Okay, that is the reason I am able to, since it is a simple ANN network and with the simple data, I am able to do it on my local machine. Otherwise, I would have needed GPU. So let us wait for this to happen. Okay, it seems it has been done. So after the training is done, we have to evaluate our this training thing, means whether it performed good or not, whether it was properly trained or not. So let us see how we do that thing. Model evaluation. So I need test loss and test accuracy. This will be equals to model.evaluate x underscore test, y underscore test, verbose equals to 1. Okay, so we have it here, test um, from model.evaluate I got test loss and test accuracy. Let me see what is the test loss. 0.4729. Okay, and what is the test accuracy? Let me check it. It is 86.14. So 86% accuracy we are getting in this. Okay. Now there is one more interesting thing that we do. We can do the visualization, training history visualization. So let us see. Actually, see these plots. No? These plots will help us to identify underfitting and overfitting and what is the convergence behavior. So plt dot figure, fig size. Say I will take 6,6. No. Plt dot plot. What do I need to plot? History dot history of accuracy. And label is equals to training accuracy. In this only, I will add plt dot plot. I need to add validation accuracy also. What has happened? Something doesn't seem correct. Okay, yeah. History dot history. Here instead of accuracy, I need to put validation underscore accuracy. And here it will be validation accuracy label. I will simply copy this from here and I'll put it here. This will be validation. See, so we have gotten a very good graph here. Same way, we can plot other graph also. Other graph is for the loss. This is for accuracy. And similarly, we have to do for loss also. I will simply copy this code. And accuracy will be replaced by loss. Label will be training loss. And here validation accuracy will be replaced by validation underscore loss. And here will be validation loss. So see, it is quite an expected graph. See, the training and validation accuracy curves, they are increasing steadily and they remain close to each other. Okay, throughout the training. Similarly, this both the losses, they are decreasing, and for both training and validation, these losses are decreasing and they are similar to each other. So this means that there means overfitting is not there. So we will conclude our project here. You will get this whole project in the description link on the GitHub. The GitHub notebook is very interesting. It has quite notes has also been provided. The code is same as the one that we have seen here. So you can practice it with yourself also. A very interesting project, a very means good project to learn new things. Okay, means a very good means for your strong portfolio of projects. Okay, thank you.